Alright, welcome class. I'm just going to explain how to do question 4 from the gravitational fields assignment. This question caused a bit of a panic, so I decided this is going to be a bonus question, but I will explain how to do this question. So the first thing, probably most important thing, is to set up a good diagram here. So let's say that we've got the Earth here, and we're given that the mass of the Earth was equal to 5.97 times 10 to the power of 24. The units of those are kilograms. And somewhere else we have the moon, and the mass of the moon was equal to 7.34 times 10 to the 22 kilograms. This was all given in the question, alright? Next thing to do, so what this question is asking for is it says that there exists a point between the Earth and the moon, so it's somewhere in the middle here, in which the attraction towards the moon and the attraction towards the Earth cancel each other out. So what we're saying is that the gravitational pull, the gravitational field from the Earth is equal and in the opposite direction to the gravitational field from the moon. So that point P is going to be somewhere in between the Earth and the moon. Now we know the distance. First of all, to keep in mind the distance from the Earth to the moon, we have to count center to center, and that's what this information here was for. So our distance from the center of the Earth to the center of the moon, the distance is actually equal to the average distance from the moon to the Earth, 3.84 times 10 to the 8 meters, plus, that's only the distance from one tip to the tip of the moon. We have to go from center to center. So we have to add in the radius of the moon and the radius of the Earth. Keep in mind these are in kilometers. This would be equal to 1.737 times 10 to the 6 meters, and this is equal to 6.37 times 10 to the 6 meters. So we have to add those in here to find the total separation between the center of the Earth and the center of the moon. Alright, adding all of those together, we're going to get 3.92 times 10 to the 8 meters. That's our total separation. That's the first part we need for this question. So we know then that from the center of the Earth to the center of the moon is 3.92 times 10 to the 8 meters. And we know that there's some point P somewhere between them. We don't know how far. We know there's got to be a point P at which the gravitational pull from the Earth and the gravitational field from the moon cancel each other out, that they're equal and opposite. So let's call this distance from the center of the Earth to this point, let's call that x. Why am I doing this? Because that's what the question is really asking for, is the distance from the center of the Earth to that point P. So now we've got the point there, that's what we're trying to find. How are we going to describe this distance here? The other side. Well, together, x plus this other distance is equal to my total distance, which we said was 3.92 times 10 to the 8 meters. So, by this logic, I know that this, we'll call it, let's call it r, and rm for the distance from the Earth to the moon, radius from the, sorry, misspoke, the radius from the moon to this point P. So we know that r value has to be equal to the total 3.92 times 10 to the 8 meters, minus x, whatever x is. We don't know yet. Hopefully we're all good up till there. If not, pause, rewind, take another look, and try to make sense of it. Moving on from there, we now have to go back to our equation here. And let's write this out in a bit more detail, moving the diagram out of the way for now. G of Earth can be written as G, capital G, times the mass of Earth over the distance from Earth to this point squared. And we know this is equal to Gm, which is capital G times the mass of the moon divided by the distance to the moon squared. So now we can put in the information that we know. We've got a lot of information that we know. And as well, before we go too far, we have a capital G on both sides, and it's the same. So because of algebra, we can cancel these out. And we're going to get that this is going to be equal to the mass of the Earth, which is 5.97 times 10 to the power of 24 kilograms, over the distance from the Earth to the point. Now going back to our diagram, the distance from the center of the Earth to our point we just called x. So it's over x squared because it's the distance squared. And this is going to be equal to the mass of the moon, which we said, which was given to us, 7.34 times 10 to the 22 kilograms, over the distance to the moon. We called that Rm in our diagram. And we had said that Rm was equal to this right here. So let's put that in here. And you're going to see you're going to end up with a quadratic there in the future. Alright, now if you set it up to here, the only hard part from here is solving. I'm going to cross multiply, which means I'm going to multiply these terms, and that's going to be equal to these terms multiplied. So I'm going to get, on a new line, 5.97 times 10 to the 24 multiplied by 3.92 times 10 to the 8 minus x squared is equal to x squared, right, this term here, times 7.34 times 10 to the 22. Expanding this, I'm not going to show all the work here. If you don't trust me, then you can run through the math yourself. I get 5.97 times 10 to the 24. And now expanding this through, I'm going to get 54 times 10 to the 17 minus 7.84 times 10 to the 8 x plus x squared. And of course that's equal to the same old thing on the other side. 7.34 times 10 to the 22 x squared. The next, sorry, forgot the bracket. This has to multiply through to each of my terms, which is going to leave me with the following: 9.19 times 10 to the 41. If your numbers are a little different, it could be just a rounding error, so as long as they're very close, I wouldn't be too concerned. Times 10 to the power of 33x plus 5.97 times 10 to the 24 x squared equals 7.34 times 10 to the 22 x squared. Off the screen a little bit there. Alright, I'm going to need a second sheet of paper to continue on here. So we've got this crazy quadratic. I'm going to try to keep it on the screen for you. We've got that. What we want to do now is make it equal to 0 and solve for x. So if we were doing this with regular numbers, it would be a bit more obvious. We just want to move everything to one side. So we want to subtract 7.34 times 10 to the 22x squared from both sides. Alright, in doing this, those are going to cancel. And what we're going to be left with is 5.897 times 10 to the power of 24x squared minus 4.68 times 10 to the 33x plus 9.19 times 10 to the 41. And this is equal to 0 now. How you solve this, I'm totally okay with you using a calculator, a computer app, anything. Don't solve this by hand. It's a pain. I'm not expecting to solve this by hand. What you're going to get is you're going to get two answers for x. When you solve this through, you're going to get x is either equal to approximately 3.24 times 10 to the power of 8, or you're going to get x is equal to 4. I got 4.99 times 10 to the 8. And again, let's just bring back our units. Distance would be in meters. Okay, we have two answers, and it doesn't make sense because way back in our diagram here, we only have 1 point. My best way to explain this is that when you do some sorts of math, they will create an answer that possibly doesn't make sense just based on the math not lining up with real life. This is one of those cases. So both answers aren't acceptable. You have to pick the right one. How are you going to pick the right one? Well, let's keep in mind the distance between the Earth and the Moon. We calculated that from center to center. We said that the distance was 3.92 times 10 to the 8 meters. That's the total distance between these two planets. Well, the Earth and the Moon, sorry. This number here, in this case, x is larger than d. Meaning the distance from the Earth to this point that's supposed to be between the Earth and the Moon is actually a larger number than the distance from the Earth to the Moon. That's physically impossible. So this value here is not a possible answer. You can see it's much larger than D, meaning that this isn't a possible answer. We have to exclude it. So the answer we actually are looking for is this one here. So this is the distance from the center of the Earth to the Moon, or sorry, from the center of the Earth to the point that we want. So here, if we're going to go back to our diagram, this is the Earth. From the center of the Earth to our point P, we know that there's 3.24 times 10 to the 8 meters, and then the Moon is somewhere over here. And at this point P, the gravitational field is going to be 0 because they're going to cancel out on both sides. And that's how you would do this question.